Hey guys, this is the video for percents on your quiz tomorrow. It'll be over percents in general, and also percent change and percent error. Okay, so I'm just going to kind of walk through what I've got here right now. Remember the original equation or relationship between things for percentages is a part of something is just equal to a percent of the whole. So if we plugged in numbers to describe this, and I'll keep them simple numbers. If 5 is the part, and remember 50% is just a decimal, you move the decimal spot 2 spots, so it's actually 0.50 or 0.5. So this is 5 is 50% of what number? Well, 5 is 50% of 10, right? The whole number is 10. The whole 100% is 10. 50% of 10 is that part, which is 5. Okay? And you could also say something like 10 is 100% or 1.00 of 10. Well, what is 1 times 10? 1 of 10, that's 10. So 100% of the whole is the whole, right? Okay, and then you could even take it one step further and find 150% of 10. Well, even though it's the part, it's going to be a bigger part than the original whole, right? Because 100% of 10 is 10. So 150% of 10 is going to be a bigger part than the actual whole. And 150% of 10, 1.5 of 10 is 15. Okay? So you can take this same relationship, and if you want to find the percent instead, well, remember, if it's percent times whole, and we want to get percent by itself, since they multiplied percent by whole, we just have to divide by the whole. And if we divide on this side, what do we got to do on this side of the equation? Well, we got to divide by the whole again. Right? Well, the whole divided by the whole is just 1, right? Anything divided by itself is 1. So those really cancel. It's just percent times 1. So you're left with the percent is equal to the part divided by the whole. That's how we got to this next thing. And that makes sense, right? Some part of something over the whole thing of it is going to give you a percent. So if we take this same example again, 5 over 10, the part over the whole, is 0.5 or 50%, right? Or 0.50, same thing. 10, the part here, over the whole, 10, is 1 or 100%. Okay? 15, the part here, over the whole 10, well, this is a bigger part than the whole, right? So this is actually going to be 150% or 1.50. Okay, and if the part over the whole is equal to the percent, then the percent is equal to the part over the whole. So that's just saying, like, if my name is Brennan, then Brennan is my name, right? My name equals Brennan. My name is Brennan. Well, you could also say Brennan is my name. Brennan equals my name. Same thing. All you did was change the order, right? Okay? So since percent is equal to the part over the whole, you can also just replace these with the other words we've been using, okay? The original amount, when you're looking at how much something changed over time, the percent change, well, the original amount is 100%, right? And then you're looking for how much it changed. How much of the original, how much part of the original did it change? Okay, same thing with percent error. It's the same process. Okay, the actual amount, however much it actually is, that's 100% of the object or amount, right? Well, however much you were off by, that's a part of the whole 100%. Okay, the error amount is a part of the actual 100% whole. Okay, so that's going to tell you some percent. Now, it's going to give it to you in a decimal form whenever you find the answer, like this, 5 over 10 equals 0.50, but you've got to change that to a percent, 50%, okay? So let's go through a couple examples here. Okay. Alright, so on this example, number 7 down here at the bottom, it says a store manager pays $40 for a t-shirt and adds a markup of 20%. During a store sale, the manager marks the cost of the shirt down by 20%. What is the percent change from the original cost, 40, to the sale price? So we already went over this in class, but I want you guys to see it again to make sure you understand. So first off, the original amount is $40. Okay. First thing they want to do, this store manager adds a markup. He increases the price by 20%. Okay. After that, he decreases the price by 20%. Now, it's not 20% of the original anymore because he already marked it up 20%. So this decrease of 20% is going to be actually more than 20% of the original. It's going to be 20% of the markup price. So we'll go into that in more detail here in a second. Okay. After that, the final thing we want to find is how much did it change by from the original price, and we want that to be found in a percent form. Okay, how much did it change from the original? Okay, so let's go through the steps. First step, we need to find what is 20% of 40, and that's going to change. That's going to tell us 20% of 40 is going to tell us how much they marked it up by. So we've got 0.2 or 0.20 of 40. Okay, if you get a calculator, you can just type in 0.20 times 40. And when you type in 0.20 times 40, you get 8. Okay. So what does 8 represent? 8's not the new price. Okay. This is the part of the whole $40 that we found, and that's how much we're going to mark it up. So it's actually going to go up $8. So now this thing costs $48. Okay, after the markup. Next step, well, he marked it down from there 20%. So we've got to now find 20%, not of $40 anymore, but of this markup price of $48. Okay, and when you find that, you get 9.6, but we're dealing with money, so it's not really 9.6. I mean, it is, but since you're dealing with money, you want 2 decimal places, so it's just 9.60. You can just throw an extra 0 on there. Now, this is not the price now again. Remember, 20% of the 48 is just how much that you take off the price. That's the discount amount. Okay? So you've actually got to take $48 and take away $9.60. So now you're at $38.40. That's the new price after the markup and after the discount. This is how much it costs. But they don't want to know how much it costs after all that. Right? Again, they want to know what is the percent change from the original cost, $40. So first off, you got to find how much did it change from the original $40 to this new price. Okay? So remember, change is just the part. So we can put change equals a percent, and the whole is the original, right? The whole amount's the original, so we can just put, so this just says the change is a percent of the original. Okay? So how much does it change? Well, we can find that. All we got to do is take the original amount, $40, and take it away. Take $38.40 away from that, okay? And then you get $1.60. Okay? So $1.60 is equal to some percent of the original. Well, what is the original? $40 was the original. Okay? So to get percent by itself again, you just got to divide by whatever it's multiplied by. You got to do the opposite. So percent is really equal to 1.60 over 40, which is the same thing as saying the change right here, 160 or $1.60 divided by what's the original amount? 40. So change over the original. And 160 over 40 is 0.04. So this percent is equal to 0.04. Well, it's not in a percent yet, so we got to move the decimal 2 spots. So it's actually a 4% change. Now, is this a 4% increase or decrease? Well, we started at 40, right? And we got to 40 or 38.40. So this is actually a 4% decrease. Okay? So we'll go over one more example. We'll go over percent error, and that should wrap it up. Okay? So let's go over this example here. At the school carnival, students are asked to guess the number of marbles in a jar to win a prize. There are 240 marbles in the jar. So 240 is the actual amount. Closest guess is 280. 280 equals an estimate. Oops. A guess, an estimate. Okay? Wants to know the percent error of that guess. Okay, so remember, and you don't have to do this formula every time, but I'm showing you where it really comes from. Part equals percent of the whole, right? And we know that. Okay, well remember, if you go back to the beginning of the video, part is actually how much you're off by. Your part is actually your error amount. And you're looking at an error is actually a percent of the whole was the actual amount. 100% is the actual real amount, right? So what is our actual amount here? Well, we've got 240, right? What is our error? How much were we off by? Well, we have to take that guess, 280, and take away 240, and we find that we were 40 off. Okay, so our error, we were 40 off. And that's equal to a percent of the actual amount, which is 240. Okay, so we're looking at how is 40 related to 240. And we want to look at how it's related in a percent form. Okay, so remember, it's just error over the actual equals percent. Well, where does that originate from again? We just took this percent times actual. We wanted to get percent by itself, right? So we just had to divide by actual here, and then divide by actual on the other side of the equal sign. So error over actual actually equals that percent. And what's our error amount? 40. What's our actual amount? 240. And that's going to equal some percent. Okay? Well, if you take 40 divided by 240, you get 0.16 repeating. And just the 6 is repeating, not the 1. Okay? So how do you change this to a percent? Well, right now it's a decimal, so we got to move the decimal 2 spots. So you would say it's 16%, but you got to remember that decimal's repeating. So when you move this decimal over, there's actually a bunch of 6's forever out there. So it's actually 16.6 repeating percent. Okay? That's how much they were off by. That's their percent error. Okay, now again, you're just really comparing how much were they off by compared to the actual 100%. Now, last thing real quick, you could set this up in a proportion. You could say 40 out of 240 is equal to some number out of 100, right? And that's just a proportion. So you can cross multiply, and you get 240x equals 4,000. Well, you got to get x by itself, so you got to divide by 240, divide by 240, and x will get you the same thing, 16.6 repeating. Okay? So you're doing the same steps, remember. Look, we multiplied by 40 by 100 and then divided by 240, right? Well, here we divided by 240, then to change the decimal to percent, we multiplied by 100, move that decimal 2 places. Okay? So it's the same steps, different order. So we went over that in class. Okay? Good luck on your quiz.